Welcome back, guys. Today's video is on binary numbers. We'll be discussing binary numbers with examples, and then we'll go ahead to discuss on the concept of number base. Let's get right into it. Binary numbers are numbers in base 2. They are made up of only two digits, 0 and 1. Let's go ahead and look at some examples of binary numbers, and then we'll discuss what number base is and what it means for a number to be in a particular base. So like we said, binary numbers can be made up of only two digits, 0 and 1. So examples of binary numbers will be combinations of 0 and 1 and then the subscript 2. So for instance, we're going to have 1, 0, and base 2. This is an example of a number in base 2. Now, our regular counting numbers, the one we use every day and for normal arithmetics, are in base 10. So if this was just 1, 0 without a subscript 2, we can call it 10. But 1, 0 with subscript 2 indicates that this is a number in base 2, will not be our regular 10. It's 1, 0, and that's how we read it as. We read it as 1, 0 and not 10. And I will explain why later. Another example of a number in base 2 can be 1, 0, 1 in base 2. We can also have 1, 1, 1 in base 2. We can have 1, 0, 1, 1 base 2. We can have 1, 0, 1, 0, 1 in base 2. We can have 1, 1, 1, 1 in base 2. You can have 1, 1, 0, 1, 1 in base 2. You can have 1, 0, 1, 1, 0, 1 in base 2, and so on and so forth. And just like we have decimal fractions in a regular counting number, we can also have binary fractions. And binary fractions are called bicimals. So let's look at some examples of bicimals. We can have 1.01 base 2. This is a binary fraction. Another example can be 101.11 in base 2. And we can also have 1 0 point say 101 base 2, and then there can be more examples, but let's stop here for now. And like I said, we're going to be discussing number base because remember in our definition of binary numbers, we say binary numbers are numbers in base 2. So what is a number base? A number base is the foundation of a number system. Now, two things we're going to be discussing about the number base today. The first one is that it defines the set of digits used to represent numbers. What does this mean? For every number base, we have a set of unique digits that you can use to represent numbers, or I would say a combination of these set of digits are used to form numbers for every base. So just like we said for base 2, also known as binary numbers, any combination of the numbers 0 and 1 can be used to form binary numbers. So 0 and 1 are the only numbers used for base 2. For base 3, the set of digits that you can use to represent numbers are 0, 1, and 2. For base 4, we have 0, 1, 2, and 3. Base 5, we have 0, 1, 2, 3, and 4. And then the same pattern goes on for base 6, base 7, base 8, base 9, and so on and so forth. So it always starts at a 0 and it ends at 1 less than the base. So the highest number you're going to get in base 2 is 1. For base 3 is 2. Base 4 is 3. Base 5 is 4, and so on and so forth. So for every base, the set of digits will be equivalent to the base. Base 2 has 2 digits. Base 3 has got 3 digits. Base 4 has got 4 digits, and so on and so forth. But the biggest number in the set of digits will always be one less than the base. So take note of that. Now, for numbers in base 10, which are regular, everyday counting numbers that we use for basic arithmetic and all of that, you can see that the set of digits used to represent numbers, they range from 0 to 9. So if you think about all our counting numbers that we use, they are made up of combinations of digits from 0 to 9. So you've got 10 digits there. Of course, highest digit there will be a 9, which is one less than 10. So this explains how the number base defines the set of digits used to represent numbers for our different bases. Now let's talk about how the number base determines the value of a number. Now we already know that the position of a digit in a number determines its value. What I want us to learn today is that every place value is a power of the base. So, for example, the number 452. Now, if you see a number like this without any subscript indicating the base, it means that this is a number in base 10. We don't bother with bases when we write our everyday counting numbers anymore. For the purpose of this illustration, I'm going to go ahead and put 10 here to indicate that this is a number in base 10, just to illustrate this. So as I was saying about place value, we know our place values increase from right to left, like you would say 100, tens, and units. So you go from units to tens and to hundreds. In the same way, the power increases from right to left. It starts at a 0, and then it goes to a 1, and a 2, and it continues to the left. So when we say that every place value is a power of the base, this is what it means. It means that we can express every digit here as a multiple of base 10, because this is a number in base 10. So for 4, we're going to have this as 4 times 10 raised to the power of 2. The 2 is coming from the power that we've written above 4. And next, we're going to have 5 times 10 raised to the power of 1 plus 2 times 10 raised to the power of 0. Now, if I simplify this, I'm going to get 4 times 10 raised to the power of 2 is 10 times 10, and that's going to give me 100 plus 5 times 10 raised to the power of 1 will give me 10. And finally, 2 times 10 raised to the power of 0 will give me 1. So this just goes to show you here how every digit in a particular base can be expressed as a multiple of a power of that base, because every place value here is a power of the base. And if I were to multiply this, 4 times 100 will give me 400, and 5 times 10 will give me 50, and 2 times 1 will give me 2. And this explains why when we talk about place value, you have 400 here, indicating that the value of 4 here is 100. You have 50 here, which is 5 tens, indicating that the value of 5 in this number is tens. And you have 2 here, so that's 2 ones, which means the place value of 2 here is unit. So this explains how the number base determines the value of a number. I want us to look up another number in base 2, since we're talking about binary numbers here. So if I have 1, 1, 1 in base 2, remember that the point we're trying to make here is that each place value here is a power of the base. So the power, in the same way as in base 10, will start from the right at 0 and increase leftward. So we have 1 and we have 2. So if I expand this just like I did for the number in base 10, it's going to be 1 times 2, 2 here being the base, raised to the power of 2, plus 1 times 2 raised to the power of 1, plus 1 times 2 raised to the power of 0. Now, if I simplify this further, I'm going to get 1 times 2 raised to the power of 2. It's going to give me 4. That's 2 times 2. Plus 1 times 2 raised to the power of 1. It gave me 2. Plus 1 times 2 raised to the power of 0 will give me 1. Now, let me quickly say that this is the building block of conversion from not just binary number, but from any base at all to base 10. This is how you're going to go about it. You're going to introduce the powers and you're going to multiply each digit here by the base raised to the powers. So if I finish this right here, the result I'm going to get will be the equivalent of 111 in base 2. I'm going to get the equivalent of that number in base 10, but that's not what we are after. If you, however, want to learn how to do a conversion from base 2 to base 10, please check out our video on conversion of binary numbers to base 10. So focusing on how the number base determines the place value of a particular number. This again goes to show why we read numbers in different bases differently. So if we see why now we can read this number as 452, but this number right here, we can read it as 111 because the value of 1 here is not 100. In fact, if I go ahead to do this multiplication, I'm going to get 1 times 4 to be 4, 1 times 2 to be 2, and 1 times 1 will be 1. So I'll read this number as 1, 1, 1 in base 2. I can read this as 452 in base 10. So this is an example of how a number base can determine the value of a number. That's it on our lesson, guys, on number base and binary numbers. Please do also check our lessons on conversion from base 10 to base 2 and also conversion from base 2 to base 10. Thank you for watching. I hope you enjoyed this video. Please do well to like, share, subscribe, and turn on the notification button so you know when we've uploaded a video. I'll see you in the next one. Bye.